Fine or fit and fine? Fit and fine. So enjoying since 2 days. Okay. So why very less number of boys? So girls are more interested towards becoming the doctor. Is it? Okay. So already I think yesterday one class was there. Sethere kodam discuss I think solutions, chemistry solutions. Okay. So myself Prabhat Behra, I will teach you chemistry. So in chemistry, 3 teachers are there. Nitish sir, who has taken one class yesterday, me, and one more Niranjan sir is also there. Okay. So basically, I will take care of organic chemistry. Nitish sir physical and to some part inorganic. And Niranjan sir will take inorganic classes and one I think amine, one organic chapter. So in organic, I have I think 6 classes total. So it is possible to teach all the topics. 11th row, I will start today one chapter that is hydrocarbons, because hydrocarbon is related to the other chapters like haloalkane, alcohol, all the chapters. So we'll start with hydrocarbon. Then we'll go to haloalkane, haloarine tomorrow. Actually haloalkane, haloarine पे 2टा क्लास दिया ताको कि हम गोटे क्लास कंप्लीट करिया पड़िबो काहे ना कार्बोक्सिलिक एसिड को पुनी टाइम होवनी. Okay, so today we'll discuss hydrocarbon, then tomorrow haloalkane, haloarine, then day after tomorrow Sunday alcohol, phenol, ether. Alcohol, phenol, ether देखिए केते complete होची. Then one more class aldehyde ketone, then amines, sorry carboxylic acid. तापरे गोटे क्लास रे हमें सब combo करिके discuss करिया. Okay, so on VST1, in VST1 you have these chapters: hydrocarbon, haloalkane, haloarine, and alcohol, phenol, ether. Okay, so organic chemistry के जनू भल लगे basically भल लगे नहीं. अच्छा ठीक है जी. So hydrocarbon रे basically 3 parts are there. जब हम देखिए hydrocarbon, one is aliphatic and aromatic. Aliphatic and aromatic. So in aliphatic, that is 3 parts: alkane, alkene, and alkyne. Alkane, alkene, and alkyne. Okay. So these are the basic division of hydrocarbon. So alkane, in all chapters we'll discuss preparation and properties. Preparation and properties. So alkane preparation properties, then alkene preparation properties, और alkyne preparation properties. Then aromatic, aromatic रे maybe हमें काली discuss करिवा, आज aromatic है परिवनी. So aromatic रे सेमती preparation basic किछ नहीं, that is basically the benzene. और तापर हैला properties means what are the chemical reactions shown by benzene or substituted benzene. जेमदन जानचो it is basically ES, electrophilic aromatic substitution. Benzene or substituted benzene is basically giving electrophilic aromatic substitution. कहेंगे addition दबनी, elimination तो दबो ही नहीं. benzene कथा दी कहबा elimination दबनी, और halobenzene भी easily elimination दिए नहीं, जोटा तमे जानी चल already कि substitution भी दिए नहीं. मन पड़ची nucleophilic substitution दिए नहीं. जदि हमर किछि minus R group थिबो then it may possible. So basically कौन होला electrophilic aromatic substitution in benzene or substituted benzene. So alkane. Alkane, what are the preparation methods you have studied? Alkane खाली मु ब्रीफ कर दोची कारण सब रिएक्शन डिस्कस करे पॉसिबल नहीं. किछि इंपोर्टेंट रिएक्शन ताको हम डिस्कस करिबा. सो लिखि दियो प्रिपरेशन ऑफ अल्कोहल, फटाफट खाली पॉइंट्स लिखि दियो, तमे ताको रिकॉल करि परिबो. Preparation of alkane. Point 1, from alkene or alkyne. Suppose you are taking alkyne hydrogen in the presence of the catalyst nickel, palladium, platinum to give first alkene, then hydrogen, nickel, palladium, platinum to give alkane. This is one method you must have studied. Second, from haloalkane. So from haloalkane, first is Franklin reaction. जानी थो Franklin reaction कौन हुए? Haloalkane in the presence of metal zinc. Metal zinc. In dry ether medium, it gives higher alkane along with zinc halide. This is the second method. Okay. Black color visible is the next. Next is black color visible is white better is white better is okay. Then second is Woods reaction. So in Woods reaction, it is again haloalkane, sodium, dry ether. So is there any limitation of Woods reaction? अच्छी किसी Woods reaction limitation? Quickly note down कर दियो. Limitations of Woods reaction. Can you prepare methane by this method? Na. हमको at least दीटा alkyl group दरकार. हेला. So first, methane cannot be prepared. Methane cannot be prepared. Second, how कौन है पेरियो? Yes, good. It is best method for preparation of symmetrical alkane, right? It is the best method for the preparation of symmetrical alkane. कहीं की unsymmetrical पाई कहीं की नुए? Because suppose हमको propane बने रच, तो then propane बनेगा, we have to take the help of CH3Cl. So what are the possible products? One is propane, another is ethane, another is butane. So तामने तीनटा product हमको मिलुची. We have to isolate the product. So isolation of alkane from alkane, that is not easy. कहीं ना समस्त chemical properties एका भली. Boiling point रे बहुत बेसी difference नहीं. So it is difficult to isolate. तामने हमें कौन करिवा? So it is not the suitable method. Again हमारा जहाँ भी suppose हम propane को isolate करिवा भी any means fractional distillation के any means. ताल से केस रे कौन हबो? Probability केते हबो? 33%. तामने हमारा कौन हैला? Probability 33%. That is not the suitable method. Okay. Next. Third limitation is we cannot take tertiary haloalkane. जब हमें tertiary haloalkane नबा sodium dry ether, ताले ऐठी कौन हबो? It is not going to give the major product as the alkane, rather alkene है जो. ता कौन कौन थी? Disproportionation reaction कोड. बुझी पालो? Tertiary haloalkane नेले से disproportionation reaction देकी, that will give the mixture of alkane and alkene. So this is not the suitable method. So I hope all of you got this. बुझा पड़ला? अच्छा. So these are the limitations. The major limitation it कौन है? We cannot prepare unsymmetrical alkane and we cannot take the help of tertiary haloalkane. तो आप में third method है Core-House synthesis. केजन जानचो Core-House synthesis? Okay. ताले एठी कोन ना sequence of reactions अछि. आमे एठी haloalkane ही नबा. So but sequence of reactions अछि. First कोन एठी अछि? Sequence of reactions lithium, so R Li plus LiX. This is first method. Second, what is the name of CuI? Cuprous iodide. Okay, so cuprous iodide nale, that will give R2CuLi plus LiI. तुम चाहिए को बालांस भी कर परिबो. डाइअल्काइल जो क्यूप्रस रो कॉम्प्लेक्स बनिला, that will be treated with haloalkane. Now here in this third step you can take the help of same haloalkane. Rx भी नहीं परिबा. So Rx नेले कौन हबो? That will give symmetrical alkane. जब मैं R dash नबा any different alkyl group नबा, then that will give unsymmetrical alkane. So बुझा पड़ला. So these are the sequence of reactions. These are the sequence of reactions in order to prepare in order to prepare alkane. अच्छा ए स्टेप रे हमें चाहिए टर्शियरी नहीं परिबा, एठी भी टर्शियरी नहीं परिबा. बुझि पड़ला. अच्छा next is from आउ कोड बनै परिबा को डीकार्बोक्सिलेशन मेथड. So under decarboxylation, one method you know, soda lime, sodium, salt of carboxylic acid, NaOH in the presence of C. So आपको हमें मन रखिया पे एमती करि परिबा RH plus Na2CO3. तुम जानी चो खाली रिएक्शन लिखि दियो तुम रिवीजन हो जिवो. आउ किछि डिटेल लिखिया दरकार नहीं. अनदर मेथड कोल्स इलेक्ट्रोलाइसिस. माने छ कोल्स इलेक्ट्रोलाइसिस. एठी हम कोन नबा सोडा लाइम रे ओनली सोडियम सॉल्ट ऑफ कार्बोक्सिलिक एसिड, बट कोल्स इलेक्ट्रोलाइसिस रे कोन सोडियम और पोटेशियम जोटा कि इजीली आयोनाइज हो पार्थिबो. सोडियम पोटेशियम इथिमे नबा जोटा कि इजीली आयोनाइज हो पार्थिबो. सो वी कैन टेक पोटेशियम electrolysis, then that will give this CO2 plus H2 plus KOH. Do you know the mechanism? मन अच्छे ना मन नहीं के जन मेकानिज्म मन अच्छे. अच्छा जने स्टूडेंट करो ठीक है फटाफट. इलेक्ट्रोलाइसिस मीन्स कौन हम ये कैथोड भी हम एनोड भी हम. कैथोड रे रिडक्शन, एनोड रे ऑक्सीडेशन. ताले फर्स्ट स्टेप रे कौन हम ये जब मेकानिज्म देखिबो that gives, then at anode oxidation, so R, that will give the free radical. So this free radical undergoes homolytic cleavage to form, then R dot will undergo combination to form alkane. This is the reaction taking place at the anode. है सो फटाफट देखिए संग से लिखी चलो. Then at cathode what happens? Reduction. अच्छा एटी reduce होने two species are available. One is K plus and another is the medium itself. बुझी पार्छ ना नहीं. मीडियम माने कोन एटी होची aqueous medium. ताले which will undergo reduction. K plus होबो ना वाटर होबो. काहे की वाटर रो रिडक्शन पोटेंशियल अधिक अछि. जार रिडक्शन पोटेंशियल अधिक थिबो से इजीली रिड्यूस होबो. सो वाटर OH minus plus hydrogen. So if you wish you can balance it. Now the question is, can you prepare alkene and alkyne by Coles phylloclysis? alkene तो ठीक अच्छे, alkene और alkyne बने परिवा की? Yes, we can. How? समझते नोट कर लो. कोई. If you are taking and upon electrolysis, what will be the product? Same steps follow करिवो. कौन होगा first? दीटा कार्बोक्सिलेट आयन होगा, तापर दीटा कार्बोक्सिलिक, sorry, कार्बन डाइऑक्साइड रिलीज होगा. Then free radical will be this. बनिवा ना नहीं? So after formation of this free radical, it can undergo two different reactions. One is the dimerization. It will form cyclobutane upon dimerization, or other one disproportionation reaction. So this is disproportionation reaction. No, disproportionation reaction नहीं. One second. ठीक है. कहीं डिस्प्रपोर्शन में दीटा फ्री रेडिकल कंबाइन हो, दैट इज द कॉम्बिनेशन रिएक्शन है. सो दिस इज नॉट द डिस्प्रपोर्शन रिएक्शन. सो दिस इज द मेजर प्रोडक्ट. This is the major product. So we can prepare alkene by using Coles phylloclysis. Now can you prepare alkyne? जदि ये beginning रो double bond थी वो, let's say, so product will be बाकी साइड प्रोडक्ट तो सेम रहेगा. इज इट क्लियर? अच्छा. सो कैन इट अंडरगो डाइमेराइजेशन? जस्ट थिंक, कैन दिस कंपाउंड अंडरगो डाइमेराइजेशन? अपॉन डाइमेराइजेशन the product will be, what is the nature of the product? Anti aromatic. Anti aromatic बनिबो बनी बुझि परलो. So dimerization product is not going to be formed, as the product formed is going to be anti aromatic in nature. So ये product बनिबो ही नहीं. Okay. So these are the methods present. ये सब मेथड ना भी ये मेथड तो नहीं, बाकी मेथड सब एनसीईआरटी रे अच्छी, कोरे हाउस भी नहीं. अच्छा, आउ किछि मेथड अच्छी जो थरा में अल्केन को प्रिपरेशन करि परिबा. आउ गोटे अच्छी से ऑलरेडी नीट और जेई रे पचारछि, हाइड्रोलाइसिस ऑफ एल्युमिनियम. व्हाट इज द नेम ऑफ दिस कंपाउंड? मेथिनाइड. कार्बाइड हेले C2 माइनस, जोटा कैल्शियम कार्बाइड आम आल्काइन पे बनाऊे. एटा एल्युमिनियम मेथिनाइड. जदि आम हाइड्रोलाइसिस करिबा, सो इट विल गिव एक्सक्लूसिवली मीथेन. इट विल गिव एक्सक्लूसिवली मीथेन. बाकी तुम बैलेंस कर परिबो. से क्वेश्चन ऑलरेडी जेई और नीट रे पचारछि आगुरु हैला. सो प्रिपरेशन मेथड्स आर ओवर नाउ. अच्छा, क्लेमेंसन और उल्फ किश्नर तमें माने aldehyde ketone बनै परिबो, but these are not the suitable methods. कहीं aldehyde ketones cannot be available in nature easily. Hello. So Clemmenson reduction and Wolff-Kishner रे देखिबो, so the reagents are Clemmenson रे ZnHg and HCl. ZnHg and HCl, and that is hydrogen and alkali medium. सेटा क्वेश्चन बेले पड़े, कैन यू टेक HCl medium in Wolff-Kishner reduction? नहीं परिबनी. Reason, hydrogen is basic in nature. Hydrogen is basic in nature. आम यदि basic nature सहित आम कौन नौचे HCl नौचे, that will form hydrogenium ion NH to NH3 plus. So that is not the suitable method. है ला. अच्छा मन रखिया जनरल confusion हुए Clemmenson and Wolff-Kishner. So मु मन रखिया इनको कहते Clemmenson Cl. So you have to take HCl. बुझी पार्छ Clemmenson Cl, so you have to take HCl. जदि HCl रहिला ताले ता सहित तो कोन रहइबो, जिंक अमालगम रहइबो, ता सहित हाइड्रोजन रहि परिबोनी. सो बेले बेले कोन हुए Clemmenson आ Wolff-Kishner भितर कन्फ्यूजन हुए को रिएजेंट कहा सहित हमें नबा हैला. सो Clemmenson Cl, that means HCl and ZnHg, आ बाकी जोटा हैला हाइड्रोजन and OH minus. Okay, so these are the preparation methods. Next एमि तो प्रिपरेशन मेथड देखल बहुत अधिक अछि, बट जेतिकी तमरो कॉम्पिटिटिव एग्जाम पे दरकार हमें सेतिकी डिस्कशन करिवा हैला. एटा जनरली aldehyde ketone चैप्टर रे डिस्कस हुए. नाउ प्रॉपर्टीज, alkanes being the saturated hydrocarbon. So saturated hydrocarbon means cannot give addition reaction. So addition reaction क्रॉस हो गला. बाकी कौन रहिला सब्स्टिट्यूशन रिएक्शन, रिडक्शन रिएक्शन. एथि रिडक्शन भी हे परिबनी, ऑलरेडी रिड्यूस्ड फॉर्म रछि, कार्बन से तो ओनली हाइड्रोजन अछि. सो रिडक्शन रिएक्शन भी हे परिबनी. आ कोन रहिला ऑक्सीडेशन रिएक्शन, रीअरेंजमेंट रिएक्शन. सो दीज आर द रिएक्शंस टू बी टेकिंग प्लेस. आ ऑक्सीडेशन रे गोटे कंट्रोल ऑक्सीडेशन हबो, आ गोटे कंबस्टन रिएक्शन हबो हैला. अच्छा सो कंबस्टन रिएक्शन कहबा दरकार नै, जो जो रिएक्शन इजी अछि मु ताको टिके ब्रीफ रे कहि दोछि, तमे निजे पढ दबो. कंबस्टन रिएक्शन एनी हाइड्रोकार्बन, if you are taking any hydrocarbon, so let it be CXHY upon combustion, that will give carbon dioxide and water, right? So how many carbon dioxide? X, and how many water? Y by 2. So it is X plus Y by 4. This is the balanced reaction. So एटा बेले बेले stoichiometry आसे, ताको कहते यूडियोमेट्री. स्टोइशियोमेट्री गोटे ब्रांच अच्छे, तो यूडियोमेट्री गोटे गैसियस रिएक्शन कहते. सो आ ये मन रखि जो वाटर बनुची दैट इज लिक्विड. जनरली ये रूम टेम्परेचर हुए, दिस इज गैस. सो बेले बेले आउपर थर्मोडायनामिक्स भी क्वेश्चन आसे, मन पड़ी डेल्टा इज इक्वल टू डेल्टा यू प्लस डेल्टा एन आर टी. डेल्टा एन मीन्स डेल्टा एन जी. सो डिक्रीजिंग और द चेंज इन नंबर ऑफ मोल्स, नंबर गैसियस मोल्स. So से केस रे कौन हुए, स्टूडेंट्स गेट कन्फ्यूज्ड कि वाटर वेदर वी हैव टू टेक वाटर इन द लिक्विड फॉर्म और इन द गैसियस फॉर्म. वाटर इन द लिक्विड फॉर्म और इन द गैसियस फॉर्म. समटाइम्स द टेम्परेचर विल बी हायर. टेम्परेचर देइथो 200 डिग्री सेंटीग्रेड. सो इन दैट केस वाटर हैज टू बी टेकन इन द गैसियस फॉर्म. यदि रूम टेम्परेचर देइछि और नॉर्मल टेम्परेचर कंबशन रिएक्शन, देन यू हैव टू टेक इन द लिक्विड फॉर्म हैला. सो सेठी कोन आर डिफरेंस कोन रहउछि ना, बेले बेले तार एनटीपी रे वॉल्यूम पचारथिबो और एसटीपी रे वॉल्यूम पचारथिबो. जदि नंबर ऑफ मोल्स देखियो गैस वॉल्यूम कहार पचारथिबो, गैस रो पचारथिबो. लिक्विड सॉलिड रो वॉल्यूम नेग्लिजिबल रहइबो. बुझि परलो. त से केस रे हमको देखिया पड़े वेदर दिस इज प्रेजेंट इन द लिक्विड फॉर्म और इन द गैसियस फॉर्म, राइट. आ क्वेश्चन न्यूमेरिकल किछि किछि पचारि छिबी, प्रीवियस ईयर रे किछि किछि न्यूमेरिकल ए टाइप रो पचारछि. व्हाट इज द कंट्राक्शन इन वॉल्यूम? सपोज वी हैव टेकन इथेन and along with oxygen upon combustion, what will be the change in volume? So इथेन किसी नंबर ऑफ मोल देइथिबो, ऑक्सीजन को बैलेंस कला ता नंबर ऑफ मोल्स मिलि जिवो. सो सेटा वॉल्यूम कैलकुलेट करि परिबा. सो इट कंप्लीटली combustion हे जिवो, that will give carbon dioxide and water. So what will be the change in volume? That type of questions can be asked, right? Okay, then another is controlled oxidation. So it NCERT देछि, although माने बहुत इंपोर्टेंट क्वेश्चन नुए, बट पचारे जदि हम कंट्रोल्ड ऑक्सीडेशन देखिबा. सपोज यू आर टेकिंग so upon controlled oxidation it can give after removing one hydrogen, after removing two hydrogen it can give aldehyde. After removing 3 hydrogen, it can give carboxylic acid. It can give carboxylic acid. So reagent देइछि but ताको conversion यूज करिवनी मन रखता ए रिएक्शन केबे conversion यूज करिवनी भूल हेजो हैला. सो रिएक्शन देइछि रिएजेंट को तमे मन रखि दबो. बेले बेले क्वेश्चन पचार दोछि कोठी मैंगनीज एसिडेट अछि कोठी मोलिब्डेनम ऑक्साइड अछि से रिएजेंट को मन रखि दबो. ओके नेक्स्ट इज आइसोमेराइजेशन. आइसोमेराइजेशन ये सब सिंपल रिएक्शन आदरे सबुठ जदि इंपोर्टेंट रिएक्शन देखिबो अल्केन रे दैट इज फ्री रेडिकल सब्स्टिट्यूशन और हालोजिनेशन. सेटा सबुठ इंपोर्टेंट रिएक्शन ता ऊपर सबुठ अधिक क्वेश्चन पचारछि नीट एज वेल एज इन जेई. सो आइसोमेराइजेशन रिएक्शन suppose you are taking n-pentane AlCl3 and anhydrous AlCl3 and HCl. So it will form isomer. It will form isomer. So this is known as isomerization reaction. Generally 1 to shift हो जाए. But alkyl group रो 1 to shift हो जाए. So that will give isomer of the compound. Okay. अच्छा. So then electrophilic substitution reaction. So electrophilic substitution reaction, it can be nitration, it can be sulfonation. So nitration again can be taking place in 2 different steps. One is vapor phase nitration, another is liquid phase nitration. So liquid phase nitration it will give the product, it is the substituted product. Suppose I propane nava. In propane, after liquid phase nitration, that will give 1 nitro or 2 nitro. This is liquid phase. And vapor phase, suppose you are taking propane, it will give these 2 products. Along with that, after cleavage of the carbon-carbon bond, कोई तरह vapor phase nitration रे. बुझ पालो. So vapor phase nitration is more vigorous as compared to the liquid phase nitration. So vapor phase रे कौन बनिबो carbon-carbon bond को break कर दे पारे. Okay. So I hope all of you got this. Nitration. Then sulfonation रे alkane ने जीवो and concentrated H2SO4 that will give alkyl sulfonic acid. That will give alkyl sulfonic acid. Simple reaction ता देखिए hydrogen जगह रे SO3H पड़े आसियो. I hope up to this clear. Okay. So the major reaction that we are going to discuss, that is halogenation reaction. Note कलो समझते? Halogenation reaction. It is the example of free radical substitution reaction. It is the example of free radical substitution reaction. 11 class रे, sorry 12 class रे haloalkane chapter रे भी तमाम पढ़ी देवो. Free radical substitution reaction. Any free radical reaction, not only substitution, it can be even addition reaction. Any free radical reaction that is always taking place in 3 steps: initiation, then propagation, then termination. Initiation, propagation, then termination. In initiation, what happens? In the initiation step, the free radical is formed. In the propagation, the reaction will be continued, and in the termination, the 2 free radicals will be combined to give a product. Okay. So that those are the 3 steps taking place in the halogenation reaction. Now, first, initiation. H nu or sunlight, that gives 2 free radical. Then propagation. Suppose you are taking CH4, मने थियो समस्तंगर CH4 एटा भी initiation step रे पळे आसीबो, that is CH3 dot plus HX. Okay. Then CH3 dot plus x2 that gives CH3x plus x dot, then CH3x plus x dot gives rise to CH2x HX, CH2, then x2 CH2 x2 plus, then CH2 x2 x dot CH x2 dot plus HX, x2 CH x3 that is halo form माने थिबो आइडो फॉर्म रिएक्शन पढ़छो halo alkane चैप्टर सॉरी aldehyde ketone चैप्टर रे then C x3 dot plus x2 C x4 plus x dot, then termination. In termination, two halogen free radicals will be combined to give halogen molecule, or you can say one carbon free radical and halogen free radical combined to give this. So this is the overall halogenation reaction. Okay, so quickly लिखि चलो किसी ने सीक्वेंस ऑफ रिएक्शन जोटी कार्बन फ्री रेडिकल बनुची से हालोजन सहित रिएक्ट करूची बुझी पारलो आउ जोटी हालोजन फ्री रेडिकल बनुची से कार्बन और हाइड्रोजन को पिक करची. सो दिस इज द सिंपल सीक्वेंस ऑफ रिएक्शन. नाउ व्हाट इज द ऑर्डर ऑफ रिएक्टिविटी ऑफ हालोजन. आम ये हालोजन कथा कहूँ आम तो गोटे खाली क्लोरीन के फ्लोरीन कथा कहूनी. हालोजन मीन्स it can be fluorination, chlorination, bromination and iodination. 4 types of halogenation reactions can take place. Talko among these 4 what is the order of reactivity of halogen? Fluorination, then chlorination, reactivity is fluorine, chlorine, bromine, iodine. जदि आम देखा what about the bond enthalpy एटा पचार NEET रे inorganic रो. What about the bond enthalpy of these 4? Yes, what are you saying? Chlorine? No, bromine. Which one? So after chlorine, bromine is there. Then at the region कौन? एटी दीटा opposite force act करे. No, one is the attraction, another is inter-electronic repulsion. जब हम देखिए फ्लोरीन रे inter-electronic repulsion अधिक होगी because in fluorine second cells are there, atom is smaller size, and around the outermost cell how many electrons are there? 7 electrons are there. यदि 7 electrons अच्छे तांको वजह strong inter-electronic repulsion होगा. In case of fluorine हवा कथा कौन? Fluorine तुम जानचो smaller the atomic size, more is the bond enthalpy. Larger the atomic size, lesser is the bond enthalpy. So order हवा कथा fluorine सबटा highest हवा कथा. But answer is chlorine. ता reason होची एटा पचार बेले बेले. P block तो अच्छी ना तुम्हारा NEET रे board से ना नथिला, but NEET रे तो अच्छी. So एथे कम पचारिबो. The reason is inter-electronic repulsion is more dominating in case of fluorine due to the small size as compared to the chlorine. So bond enthalpy is higher in case of chlorine. बुझा पड़ला. आम ये बॉन्ड एंथैल्पी एथमे मैं दीटा डिस्कस करछि कारण दीटा इधर कंफ्यूजन हुए. बॉन्ड एंथैल्पी एठी कोन? बॉन्ड एंथैल्पी में हम तो बॉन्ड को ब्रेक करूछे आ एठी हम कोन करूछे फ्री रेडिकल फॉर्मेशन करछे. सो दीज आर नॉट एक्जेक्टली द सेम थिंग. सो इन केस ऑफ फ्री रेडिकल सब्स्टिट्यूशन इट इज फ्लोरीन, क्लोरीन, ब्रोमीन, आयोडीन. All of you got this? Fluorine, chlorine, bromine and iodine. Now from this order it is clear that fluorination is most reactive and iodination is most least reactive or very slow. Okay. अच्छा. So यदि most reactive होबो तार consequence कौन होबो? तार result कौन होबो? और यदि least reactive होबो ताल तार result कौन होबो? So most reactive ले सब जगह अटैक करि परिबो. खाली सेति कि नुहे. क्लोरीन भी तो सब जगह अटैक करूची. So it आउ गोटे जिनस कौन हम? इट कैन इवन ब्रेक द कार्बन कार्बन बॉन्ड. सपोज आम इथेन नौचे. सो इथेन नेले कौन बनिवो फ्लोरो इथेन तो बनिवो ता सहित फ्लोरो मिथेन भी बनिजो कार्बन कार्बन बॉन्ड को ब्रेक कर दबो सो फ्लोरिनेशन इज मोस्ट विगोरस रिएक्शन सो दिस इज नॉट गोइंग टू टेक प्लेस बुझि पारलो सो फ्लोरिनेशन हमें एक्सेप्ट करबानी फ्लोरिनेशन नॉट एक्सेप्टेड तुम के बताला हमें फ्लोरीन केमिति बनेबा जस्ट ट्राई टू रिकॉल हालो अल्केन चैप्टर हालोजन एक्सचेंज स्वार्ट्स रिएक्शन माने पड़ला अच्छा सो मोस्ट रिएक्टिव सो इट इज अवॉइडेड देन आयोडीनेशन दैट इज वेरी लीस्ट रिएक्टिव और वेरी स्लो जो स्लो रिएक्शन थाए दोज आर जनरली रिभर्सिबल रिएक्शन जमी तुम सपोज कुआड जीवा इच्छा नहीं तुम घर क्वेश्चन जाओ तुम कौन कर जीव कि बार जीव जाऊ टे ठिया जाऊ घर कहे ठीक अच्छे जा बस आसिक पुणी बस पड़ो सो दैट मीन्स जो स्लो रिएक्शन था जनरली दोज आर द रिभर्सिबल रिएक्शन सो आयोडीनेशन इज वेरी स्लो एंड रिभर्सिबल सो दैट इज नॉट वाइज टू बी फॉलोड बाकी कौन रहा क्लोरिनेशन एंड ब्रोमिनेशन सो बिटवीन क्लोरिनेशन एंड ब्रोमिनेशन व्हिच इज मोर रिएक्टिव क्लोरिनेशन then what about bromination more selective what about bromination more selective so chlorination is more reactive and bromination is more selective so that topic is known as reactivity versus selectivity reactivity versus selectivity so जमती तुम कह सपोज यू डू नॉट लाइक एनी फूड ओके सपोज क्या डालमा खाया पसंद नुहे बट यू आर फीलिंग हंग्री सो व्हाट विल हैपन विल यू टेक और नॉट ओके दैट इज रिएक्टिव तुम पसंद थाओ कि न थाओ बट यू हैव टू टेक बिकॉज यू आर हंग्री सपोज यू हैव टेकन समथिंग फ्रॉम आउटसाइड आ हॉस्टेल कौन बनी डालमा बनी कौन कर खाइबनी बिकॉज यू आर नॉट फीलिंग हंग्री जब तुमको किसी तुम पसंद किसी खाया बनथो देन यू कैन टेक सो दैट इज द डिफरेंस बिटवीन रिएक्टिव एंड सिलेक्टिविटी जो भोक लगुच यू आर नॉट गोइंग टू चूज एनी फूड जो भोक न लगुच यू विल टेक द फूड ऑफ योर चॉइस नॉट ऑल द फूड्स सो सिमिलरली क्लोरिनेशन इज मोर रिएक्टिव एंड ब्रोमिनेशन इज मोर सिलेक्टिव सो as a result of this suppose you are taking this compound okay so in chlorination what will happen all possible products will be formed but in case of bromination major product will be formed so this is the meaning of reactivity versus selectivity okay so the quickly note down few questions quick write down the products लिख लो समझते राइट राइट रीड प्रोडक्ट लिख लो फिर कहीं नो राइट द क्वेश्चंस ना दीज आर द 4 क्वेश्चंस आई हैव गिवन सॉल्व हाउ मेनी वन मोर ट्राई यस वन मोर Now, in the first case, how many different carbon atoms are there? Why I have written 2 4? Because both the carbon atoms are identical. So how many products will be formed? 4 products will be formed. Okay. So the products are, can you identify the optical isomers among these 4? This is also one of the previous JEE question. Optical isomer. Mane padchi chiral center. So what is chiral center? If the carbon is attached to 4 different atoms directly, 4 different atoms directly, then that is known as the chiral center. So in this case, this is the chiral center. Yes or no? One hydrogen, this is CS2Cl, CS3 and C2H5, chiral center. Again, here it is also chiral center. See, if the chiral center is there, it will be having 2 different compounds. Chiral center means 2 different compounds. One is D, another is L. Mane padchi? Dextrorotatory and levorotatory. Tale here, including the stereoisomers, how many products? 6 products. If stereoisomer mention न करथिबो, then 4 products. If stereoisomer पचारथिबो, in total products including the stereoisomer, then the answer will be 6. अच्छा, आउ थरे एमि क्वेश्चन पचारथिला जेई रे, ए क्वेश्चन देइथिला कोन पचारथिला, आफ्टर फ्रैक्शनल डिस्टिलेशन how many isomers are formed? हाँ, सब तो आइसोमर ना. After fractional distillation, how many isomers will be formed? Answer is 4. कहीं ना स्टीरियो आइसोमर को और ऑप्टिकल आइसोमर को we cannot separate it by the process of fractional distillation. You know, in distillation, what is the minimum criteria? In distillation, the minimum criteria is boiling point difference should be 25 degree, minimum 25 degree. So the boiling point difference 25 degree not, then we cannot separate. Like ethanol and water, can you separate by distillation method? Ethanol boiling point 78 degree centigrade, water is 100 degree, so 22 degree. We cannot separate it by the method of normal distillation. But fractional distillation kari pariba. Fractional distillation criteria kono, minimum boiling point difference should be 10 degree. So it hame jo nauche kono na optical isomers. So optical isomers do not have the boiling point difference of 10 degree. So those cannot be separated by using fractional distillation. ताले यदि fractional distillation रे एटा चाहूचे नोट कर लिखि परिबो, optical isomers cannot be separated by using fractional distillation. Optical isomers cannot be separated by using fractional distillation. ताले after fractional distillation कोन हबो? 4 हे जिवो. Okay, in total केते ले 6, after fractional distillation 4. Second, only tertiary product. Okay, then third, all are identical, so doesn't matter whether this is chlorination or bromination, single product will be formed. तापे गोटे अच्छी मैथमेटिकल एक्सप्रेशन भी अच्छी, ता कोनते प्रोबेबिलिटी फैक्टर, जानचो के जन प्रोबेबिलिटी फैक्टर जानचो, ता देरे ठीक अछि, नोट कर दियो, ताकू फटाफट कहि दउ छे. Noted? Okay. Probability factor, reactivity of hydrogen into number of hydrogen atoms. Number of hydrogen atoms. So here it is type of hydrogen, chlorination, bromination, primary, secondary, tertiary. Tell what is the reactivity order of the hydrogens, primary, secondary, tertiary. You know, this is tertiary greater than secondary greater than primary. That means slow reaction कोठी हबो, primary case रहो. यदि primary slow reaction हैला, we can consider it as one. It may be chlorination or bromination. So with respect to primary, secondary in case of chlorination, it is either 3.5 or 3.8. According to different book, different answers are written. So it is 82. And tertiary 5, it is 1600. Now you can see. That I put a quick example now. Suppose this here it is primary, 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 and this is tertiary. So in chlorination, primary reactivity hydrogen is 1 into number of hydrogen 9, and tertiary reactivity hydrogen is 5, number of hydrogen is 1. And what about bromination? A primary 1 into 9 and tertiary 1600 into 1. Now you see the difference. Chlorination case रे आम देखिए प्राइमरी रो वेटेज अधिक होची as compared to tertiary. Yes or no? But दीटा comparable. गोटे 9 रे गोटे 5 रहिला. So आम कहा को मेजर प्रोडक्ट कहि परिबानी. But in case of bromination 1600 is to 9. That means the tertiary product is the major product. ता कोन probability factor. हैला एटा मैथमेटिकल एक्सप्रेशन. आ गोटे जिंस मन रखि दाओ. ये जो आम probability factor देखुचे that is at room temperature or moderate temperature. एटा भी को एग्जाम रोट आसी थिला. मे बी आगुरु एमसी एग्जाम आसथिला. लिखि दियो at higher temperature, एटा नोट कर लिखि दियो. At higher temperature, that is 300 degree centigrade or above, 300 degree centigrade or above, the reactivity of all three, the reactivity of all three, that is 1 degree, 2 degree and 3 degree are the same. 1 degree, 2 degree or 3 degree are the same. Clear? Hello? So, ये order केतल होगा room temperature होगा moderate temperature होगा, not at very high temperature. So, with this the alkane chapter is over. Okay. Then alkene. What are the preparation methods? From alkyne. Now, if we are taking this alkyne and with the same set of reagents, nickel, palladium, platinum, can the reaction be stopped at the alkene stage? I am already देखिचे alkyne रो हम alkene बनेले, alkene देना alkene बने देले. So reaction cannot be stopped at the alkene stage. So we have to take different set of reagents in order to stop the reaction at the alkene stage. That is the first question. Second, when the alkene will be formed, it can exhibit geometrical isomerism. तुम जानते geometrical isomerism होगा alkene रे. It may be cis alkene, it may be trans alkene. ता माने cis और trans alkene पे हमको different set of reagent नवा पड़ेगा. We have to take the different set of reagents in order to prepare cis and trans. So first cis alkene. So ताप हमें catalyst कौन नोचे? Lindlar catalyst. So हमें देखिए palladium नोचे ताले कौन होगा? Reaction alkane पर्यंत जाऊँगी. हमको reaction को alkene stage stop करियर अच्छी. ताले palladium सो एमिति गोटे palladium is what? That is catalyst. So along with catalyst we have to use the catalytic poison or inhibitor. तुम जानते हो promoters are increasing the reactivity of catalyst and inhibitors are decreasing the reactivity of catalyst. So we have to use catalytic poison or inhibitor. So what are those? Along with palladium, it can be barium sulfate or quinoline or partially deactivated charcoal. Partially deactivated charcoal. And in other books it is also written calcium carbonate. So anchor function kono? The function of these substances are to cover, right? These substances cover the active surface area. These substances cover the active surface area of the catalyst, active surface area of the catalyst, after formation of alkene. After formation of alkene. Achha, you know what is the order of reaction? Zero order reaction. Mane padchi chemical kinetics. Why zero order reaction? Because this is the gaseous reaction in the presence of solid catalyst. Jodi se jinso bujhi paribo akku bujhar kichhi asubidha nahi. So how the mechanism takes place? The mechanism is on the surface of the solid catalyst, both the gases, it may be hydrogen, it may be alkene, both are alkyne, both the gases are getting adsorbed. So hydrogen interacts with the alkyne, alkene will be formed. Once alkene will be formed, it will be regenerated, it will be escaped from the surface, absorb. But before getting absorbed, what will happen? The surface area will be covered by this catalytic poison. Surface area will be covered by this catalytic poison. So it cannot go further. The reaction cannot proceed further. So why it is independent of the concentration? Because it is dependent on the active surface area of the catalyst. Zero order kinetics. Mane padchi zero order kinetics au kichi reaction te padithibo photochemical reactions. Okay. Next, transalkene. So this reaction is known as Wurtz reduction. Okay, and it is along with hydrogen, it is giving lithium and liquid ammonia or sodium liquid ammonia. So the product is, it is cis, and here this catalyst, that is trans. I hope all of you got this. जो assignment मिली समस्या try करिवो, answer key is given on the last page. Try कला परे we will discuss in the next class tomorrow if you have any doubt. So NEET level questions are given. So this one is clear. Hydrocarbon एथे detail discuss कर because this is the 11th chapter. So generally students forget the 11th chapter. But आपरे जो halo alkane आसो तादर detail discussion करा दरकार पड़िबनी. But hydrocarbon टा 11th chapter से detail discuss करूची. Right. So next, other method, halo alkane. Elimination. So this is already discussed in the class 12. Now write some questions. Alcoholic KOH. Take 2 minutes, write down the products because halo alkane is already there in the class 12 syllabus. Okay, so write down the products, possible products, and you have to mention the major product also. All of you are doing? What is the mechanism? Can anyone say? First step, it can be elimination reaction. How many types of elimination reactions are there? 3 types. E1, E2, then E1CV. Elimination unimolecular in the presence of conjugate base. Before that, E1 and E2. E1, E2. So E1CV को मुझे डिस्कस कर देबी. First, if you take, what will happen? The carbocation will be formed. Okay, अच्छा. But एक केस रे कौन? This is the product. In this case, it will be E2 mechanism. this will be E1 mechanism, this is E2 sorry E1 mechanism. मन पड़ी what is E1 and E2 mechanism कौन? Just try to compare E1 and SN1, E2 and SN2. E1 and SN1 the intermediate is carbocation. E2 and SN2 the intermediate is or the reaction goes through concerted mechanism. मन पड़ी concerted mechanism, bond formation and dissociation both are taking place simultaneously. Bond formation and dissociation both are taking place simultaneously. So that is going to follow concerted mechanism. So एठी carbocation बनिवनी. जदि carbocation न बनिवो, the product will be this. Which bello? The product will be this. In this case, carbocation will be formed. So what carbocation will be formed? This. So what will be the major product? How many of you know carbocation rearrangement? केजन जानछो carbocation rearrangement? Raise your hand. अच्छा. So carbocation rearrangement question पचारुची already. बोधे last year बोधे कोटे question पचारथिला related to the carbocation rearrange जोटा alcohol formation रे कि haloalkane formation रे even alkene formation रे भी आसे. अच्छा. So carbocation rearrangement. Write down quick. Heading carbocation rearrangement. Carbocation rearrangement. Now listen, carbocation is one of the intermediate, and what is the order of stability of the carbocation? Tertiary greater than secondary greater than primary. So during the course of reaction, if any primary carbocation is formed, that may undergo rearrangement to form either secondary or tertiary. Okay, either secondary or tertiary. So if it is secondary or tertiary, then that will give the major product as compared to the primary one. And again, with the increase in ring size, ring expansion can take place. Suppose cyclopropane, cyclobutane and cyclopentane. What is the order of stability? Cyclopentane is more stable than cyclobutane, then cyclopropane. The reason is now with the increase in ring size, steric crowding decreases, steric strain decreases. जोटा कि ring size increase stability increase हुए. So another case कौन है ring expansion और ring contraction. So there are 4 steps by which carbocation rearrangement may take place. One is hydride shift, then alkyl or phenyl shift, ring expansion, then ring contraction. Ring expansion, then ring contraction. So these are the 4 methods by which the rearrangement of carbocation may take place. Okay, rearrangement of carbocation may take place. So first, suppose you have this carbocation. It undergoes hydride shift. Which fellow? It is primary. This is secondary. Which is more stable? Secondary more stable. So as a result of hydride shift, primary is converted to the secondary. बुझा पड़ला हाइड्रेट शिफ्ट बुझ पाला तो हाइड्रेट को फॉर्म रे शिफ्ट हो H माइनस फॉर्म रे शिफ्ट हो कहीं कार्बोकेटन सेंटर को जाउची कार्बोकेटन सेंटर केमि जीवो H प्लस फॉर्म में जीवो H माइनस फॉर्म में जीवो इट हैज टू कैरी द इलेक्ट्रॉन डेंसिटी सो H माइनस आइगला हाइड्रेट शिफ्ट फर्स्ट पॉइंट क्लियर ओके नेक्स्ट अल्काइल और फिनाइल शिफ्ट सपोज this is the carbocation this is secondary after methyl shift this becomes tertiary which bello so which is more stable of course tertiary is more stable than the secondary सिमिलरली फिनाइल शिफ्ट हम आर क्वेश्चन आम करवा कौन कहला अल्कोहल चैप्टर गोटे अच्छे पिनाकोल पिनाकोलोन रिअरेंजमेंट से हम डिस्कस करिया जोटा तुम एनसीईआरटी पढ़ी नथिबो बट केबे केबे नीट एग्जाम रे पचार दोछि पिनाकल पिनाकलोन रीअरेंजमेंट अप टू दिस क्लियर देन रिंग एक्सपेंशन नोट कर लो सपोज you have 5-membered ring and at the adjacent position, that is alpha position of the ring, one carbocation center is formed, then that will undergo ring expansion. So this one will be dissociated to form. So first you have to draw 6-membered ring, then put the numbering with position 2 carbocation center will be formed, because this is going to जोटा में 6 mark करचे, that is going to make the bond, so that has to carry the negative charge along with it. यदि 6 पाखे negative charge रहिला, the bond has to be undergo heterolytic cleavage. So heterolytic cleavage हेले कौन होबो 6 पाखे यदि negative charge रहिला 2 पाखे कौन रहिबो positive charge रहिबो. This is the carbocation. तमें कहबो after the expansion the stability increases, so ring expansion is understood. Then how the ring contraction will take place? And last point थला ring contraction सब केस रे होबनी. You might be knowing, do you know this carbocation? Resonance is always dancing. Got my point? एटा न्यू टर्म आगुरु आमे केबे ए टर्म सुन नथल बट एबे गोटे न्यू इन्वेंशन आसीगला किछि किछि टीचर दा कहदे डांसिंग रेजोनेंस और डांसिंग रेजोनेंस चलछि हला बट रेजोनेंस इज ऑलवेज डांसिंग हाउ इट इज डांसिंग आई विल से सो व्हाट इज द नेम ऑफ दिस साइक्लोप्रोपाइल मिथाइल कार्बोकेटायन साइक्लोप्रोपाइल मिथाइल कार्बोकेटायन जदि हम नबा डाई साइक्लोप्रोपाइल then cyclopropyl. So it is one of the most stable carbocation which is isolated till date. Tricyclopropyl methyl carbocation. Okay. Tale ring contraction is not going to take place always. Suppose this, it can undergo ring contraction to form this. Very rare case रे ring contraction हुए. कहीं के ना ring size increase ले stability increase हुए. So ring size decrease ले very rare case रे stability increase हुए. बुझा पड़ला? Okay. अच्छा now, why did I say yes? कहीं की पचार? See, up to 6-membered ring, the stability increases. That is universal. But after the 6-membered ring, 7-membered ring may or may not be more stable. It depends upon other factors. Like, do you know this carbocation? What is the name of this carbocation? Tropylium carbocation. This is 7-membered, but this is one of the highly stable because it is aromatic in nature. Okay. So in this case, it is more stable. Aromatic in nature, but not always. But up to 6, it will increase. Up to 6, the stability increases. Even cyclopropane is unstable. It can undergo addition reaction to form propane. Cyclopropane is highly unstable. So up to this clear? So the term I told, resonance is always dancing. What is the meaning of that? Dancing means what? Vibration? Yes or no? So in resonance, what is taking place? Delocalization of electron takes place. Jadi delocalization resonance, जोठी भी resonance हो सेठी delocalization होबो. तो resonance हेला नहीं कि माने dancing हेला नहीं कि. Yes or no? हाँ, एक केस रे एबे ताको term दे दे dancing resonance. आपको जे bent p orbital. जेते सब स्टैंडर्ड बुक देखिबो ऑर्गेनिक रो सब दे लिखि बेंट पी ऑर्बिटल जोटे के एठी प्रेजेंट अछि से कोन हबो ना स्टेबलाइज हो जिवो हैला ओके सो अप टू दिस क्लियर नाउ कम बैक टू द क्वेश्चन this question. First, carbocation will be formed. This is the carbocation. Can it undergo rearrangement? Yes. Put the numbering. एटी किसी सब्स्टिट्यूट नहीं बेले बेले सब्स्टिट्यूट नंबरिंग नदेले तुम्हें भी कन्फ्यूज हो सो एट द पोजिशन 2 दिस एंड एट द पोजिशन 1 दिस अगेन इट इज सेकेंडरी इट कैन अंडरगो द रीअरेंजमेंट टू फॉर्म टर्शियरी हो पार ना नहीं बाय हाइड्राइड शिफ्ट then the final product will be this alkene. Got the product? So this product is obtained as a result of carbocation rearrangement. This is the product of carbocation rearrangement. Note kalo quick. क्लास केतरे बेले अछि अंकर क्लास केतरे बेले अछि हे नै 3 डाले अच्छा बदे 11:15 थिबो टिका अधिक नै जिबा अच्छा स्टूडेंट योर क्लास इज देयर अप टू 11:15 देन आफ्टर दैट यू हैव अ लॉन्ग ब्रेक सो कैन वी टेक 5-10 मिनिट्स मोर ना बोर हे गेलानी लागु बोर हे गेलानी के किछ कहू ना चलो ओके हाँ कौन कहलो कि कहूच चलो ओके कारण आप ब्रेक अच्छे लंबा ब्रेक टिके कारण हाइड्रोकार्बन बहुत जिन अच्छे डिस्कस करने को सो अप टू दिस क्लियर ओके नेक्स्ट next is dehydration of alcohol. I think no need to discuss. एटा तुम 12 क्लास पढ़ी dehydration of alcohol. Okay. So what are the other methods? From vicinal dihalide metal zinc ZnCl2. Actually these are the methods given in your NCERT. Another thing, this method is not suitable method. Last one, preparation of alkene from the vicinal dihalide is not the suitable method. The reason kono na generally vicinal dihalides are prepared from alkene. Alkene plus halogen that gives vicinal dihalide. So it is not the suitable method. Still we can use it in order to prepare. Okay. So last method that is not there in NCERT, heating quaternary ammonium salt. So quaternary ammonium salt means with nitrogen 4 alkyl groups has to be there. When it is heated, that releases one alkyl group right? Which alkyl group will be released or which alkene will be formed? तुमको आम पाखे तो कौन थिला इथाइल ग्रुप थिला इथाइल प्रोपाइल ब्यूटाइल मिथाइल तो बनी सो व्हाई इथाइल नॉट प्रोपाइल एंड ब्यूटाइल राइट alkene with least possible number of alkene with least possible number of carbon atoms will be formed. Least possible number of carbon atoms will be formed. Okay. So these are the preparation methods of alkene. Then properties of alkene. Alkene being the unsaturated hydrocarbon can easily undergo addition reaction. Alkene being the unsaturated hydrocarbon can easily undergo addition reaction. So the addition reaction easily dabo, then what will be the product? First, write down the products quickly. These reactions you know already. Quickly complete the reactions. This is Hg. Take 2 minutes. Write down the question and product. Okay. So first it is propane, then 2-chloropropane, writing the products first. Compare with your answer. In alkene, the hydration can take place in 3 different modes. One is direct hydration, जोटा हमें कौन नौचे water along with the dilute acid. Okay, dilute acid, direct hydration. Then another is hydroboration oxidation. Then last one is oxymercuration, deoxymercuration. Achha, how many of you know the first direct hydration? All of you might be knowing. कारण तो alcohol chapter थिला. अच्छा, हाइड्रोबोरेशन ऑक्सीडेशन के जन जानछो जानछो तो अच्छा देखो हाइड्रोबोरेशन ऑक्सीडेशन रे कोन ना जोठी भी तमरो सपोज दिस इज द कंपाउंड इफ यू आर टेकिंग B2H6 H2O2 it follows Markovnikov rule, but the product is anti-Markovnikov product, so terminal alcohol. Hydroboration oxidation is useful for the formation of terminal alcohol. Got this? Achha. Another. In direct hydration, the major limitation is it goes through the formation of carbocation intermediate. जब हम एक केस से देखेंगे. Okay. So first carbocation will be formed at this place, secondary, then it will be rearranged by undergoing hydride shift, tertiary carbocation will be formed and the product will be this product. This is the rearranged product. But in oxymercuration, deoxymercuration, there will be no formation of carbocation intermediate. So the product will be direct Markovnikov product. All of you got this? So it carbocation rearrangement hobo, but oxymercuration deoxymercuration re carbocation baniban to rearrangement kout hobo. Hello. So the mechanism you can write first. What is this? Mercuric acetate. Acetate ion को short form रे OS लिखा जाए. This plus charge, then water कोठी का attack करिवो to the most stable carbocation center. This then release of mercury will be taking place by the help of reducing agent NaBH4. So this is the set of reactions. Oxymercuration, that means addition of mercuric acetate. Then deoxymercuration, removal of mercuric acetate. Removal of mercuric acetate. So I hope all of you got this. Up to this clear? Okay, quick. Our major reaction कौन रहिला alkene रे oxidation reaction. In alkene the major reaction is oxidation reaction. So oxidation can be taking place first by mild oxidizing agent, second by strong oxidizing agent, then third by ozonolysis. So all of you must be knowing ozonolysis under the chapter aldehyde and ketone. Okay. So first by mild oxidizing agent, quickly note down, by mild oxidizing agent. So what are the mild oxidizing agent? That is Bayer's reagent. No, that you are saying na, PCC, PDC or Jones reagent, Collins reagent, that is mild oxidizing agent for alcohol to aldehyde and ketone. But here we are discussing a mild oxidizing agent for alkene, Bayer's reagent. So what is Bayer's reagent? That is cold dilute KMnO4. So it makes syn hydroxylation. It makes syn hydroxylation. Suppose we are taking the alkene, Bayer's reagent. So what is the meaning of syn hydroxylation? Syn means on the same side. Hydroxylation means addition of OH. Syn means on the same side, hydroxylation means addition of OH. So that is, you can say vicinal glycal. Next, under the mild, osmium tetroxide, OSO4. Very rare elements are there in the periodic table to exhibit plus 8 oxidation state. In the periodic table, very rare elements are there to exhibit plus 8 oxidation state. So osmium tetroxide is one of the example. XCO4 is another example. Okay. So sometimes the questions are asked in assertion region. No metal can exhibit plus 8 oxidation state. That is incorrect. Osmium is there. Right. So same as Bayer's reagent. Same as Bayer's reagent. Okay. The last one, under the mild oxidizing agent, that is per carboxylic acid. You know carboxylic acid is RCOOH. So per carboxylic acid is RCO3H. Peroxide linkage is there. So it is highly unstable. Okay. So if we are taking this alkene in the presence of, that makes epoxide first. You know cyclic ether. So this will make epoxide first. Okay, cyclic ethers are otherwise known as epoxide. Then upon reaction with dilute acid, it gives, so it is trans hydroxylation. It is trans hydroxylation. Is it clear, students? I hope all of you got this. बुझा पड़ला. So एथिरे कौन है तमर बेयर्स रिएजेंट आउ ऑस्मियम टेट्राऑक्साइड सिन हाइड्रोक्सिलेशन आ एक केस रे कौन है ट्रांस हाइड्रोक्सिलेशन. सो ऑस्मियम टेट्राऑक्साइड पर कार्बोक्सिलिक एसिड एनसीएडी नाही बट स्टिल एग्जाम रे क्वेश्चन पचारे छी. So up to this clear? So this is by the use of mild oxidizing agent. Then strong oxidizing agent, right? Second, strong oxidizing agent. So what are the strong oxidizing agent? Alkaline KMnO4, acidified K2Cr2O7, then H2CrO4. If you are taking CrO3 along with pyridine, CrO3 pyridine, that is mild oxidizing agent, but CrO3 along with water, that is strong oxidizing agent. CrO3 along with water, that is strong oxidizing agent. So what will be the reaction? Suppose alkaline KMnO4. So it will make complete cleavage of the carbon-carbon bond to form mixture of carboxylic acids. If the alkene is suppose acidified K2Cr2O7, it will be ketone, because after formation of ketone it cannot undergo further oxidation. Ketone बोलना पर oxidation केमती हबो हे परिबनी, it cannot undergo further oxidation. So that one is clear. So write down the products. Write down the products. This is one of the terminal alkene. So upon oxidation, the terminal alkene will be converted to carbon dioxide. Terminal alkene, that will be converted to carbon dioxide. So this is carbon dioxide plus then CS2, then got this, all of you? So write down, if it is terminal alkene, then it will be undergoing oxidation to give carbon dioxide as the product. Okay, quickly note down. So last reaction, that is ozone lysis. All of you know already, aldehyde ketone chapter, ozone lysis. So I am going to give 2 questions from ozone lysis. So then the class will be over. Completed this reaction. So last reaction, ozone lysis. So student, remember, ozone lysis can be taking place in two ways. One is reductive ozone lysis and another is oxidative ozone lysis. In reductive ozone lysis, the reagents are zinc water and zinc acetic acid. That is reductive ozone lysis. And in oxidative ozone lysis, the reagents are O3 along with H2O2. O3 along with H2O2. So quickly write down, upon oxidative ozone lysis, aldehyde formed can undergo oxidation. So what will be the product? Aldehyde oxidation hele kon banibo? Carboxylic acid. Good. Undergo oxidation to form carboxylic acid. But here we are going to discuss the reductive ozone lysis. So just try to recall, if this is the reactant, then in first step, this what will be formed? Ozonide. Yes or no? This is ozonide. Then the cleavage of ozonide, this. So the products are from the left side, acetone, then this, then what is the name of this? Glyoxal, common name, and IPAC name ethane 1,2-diol, ethane 1,2-diol or glyoxal. Last one, can you write this way? So then ozonide, yes or no? So across both the double bond, ozonide formation takes place. Then this, so it is CTH5. How many products are formed? 2. CTH5, CHO. Here CH3, then CH, CHO. So you can write down the IPAC name. Okay students, all of you got this, the reactions of alkane and alkene. Alkane reaction just similar. जब आम ये addition देखुचे, only one molecule is undergoing addition, सेठी कौन हम? 2 molecules हम, maybe 2 molecules of hydrogen, 2 molecules of halogen, 2 molecules of HX. So that will give the product. So try the questions that you have got in the form of assignment. आउ तुम पाके जहाँ भी book तमर अच्छी, you can solve some questions. In case any doubt, you can ask me on tomorrow. So tomorrow you have class. So tomorrow we will discuss haloalkane and haloarine. So some reactions are similar in hydrocarbon as well as haloalkane, haloarine. Okay students.